Hello, so now that we've gotten the anatomy of the kidney out of the way, we're going to talk a little bit more about the nephron. And the nephron starts up here with this little sphere, and then it has this little convoluted tube coming out, comes down, does a loop-de-loop, and empties out into a collecting duct that goes all the way down through the pyramid and empties out into the minor calyx. So this is all the nephron is going to be in the pyramid region and the outer cortex region in the kidney. So the nephron is going to be start in the cortex above the pyramid, and then it's going to go down into the pyramid. And there's two types of nephrons. There's the type that I just drew, which is mostly in the cortex region, and that's called the cortical nephron. And then there's another type of nephron that it's really similar, but it starts with the little sphere here, and it does the convoluted, twisty, turny thing, and then it comes down a lot further down into the pyramid, does a loop-de-loop, comes back up, is more convoluted, and empties out into the collection duct, which goes down through the pyramid and into the minor calyx. So that's called the juxtamedullary nephron because the loop dips down into the medulla area a lot more. See how it dips a lot more down into the pyramid, into the medulla area? So we're going to be dealing with this part of the kidney, this area of the kidney right here, talking about the nephron. So here is a drawing of just a close-up of that area that I just circled in the kidney. There's the pyramid. There's the pyramid right here. There's a column on either side of cortical tissue. And then up here is the cortex on the most superficial layer. And, well, actually, the most superficial layer is the fibrous capsule up here. That's like the skin of the kidney, the tissue that surrounds the outside of the kidney. But the innermost, or the inside layer, the superficial layer, is called the cortex. So the nephron starts with the renal corpuscle, and it's this little sphere. And the renal corpuscle, we'll get into the renal corpuscle in a little bit, but it starts out, the nephron starts out with this little renal corpuscle, and then there's a tube that comes out, and this is where the filtrate, or what's going to be the urine, comes out this little tube, and it does this little convoluted mess. And convoluted just means intricate twisting and turning. And so it does this convoluted mess. It goes down, does a little loop, and then it comes back up, does another little convolution, and it empties into the collecting duct, this duct here, that goes all the way down through the pyramid and empties out into the minor calyx. And then, as I was showing you on the other picture, there's the other kind of nephron, the juxtamedullary nephron, which starts same thing with the renal corpuscle. It does a little convoluted mess there, goes down, but this one goes way down into the pyramid, very long, does a little loop-de-loop, comes back up, does a little convoluted twisting and turning, and empties into the collection duct. So this one, the one that is mostly up in the cortex, is called the cortical nephron. And this one that goes all the way down into the medulla area is called the juxtamedullary nephron. And here's here's a diagram of the same thing I was drawing, but in this picture the cortical nephron is on the right instead. And as you can see, the cortical nephron, it does that loop-de-loop. Here's the loop, and it just goes down and just barely touches the pyramid. This is the cortex region. So this loop only goes down to the top of the pyramid and it stays mostly in the cortex, so that's why it's called the cortical nephron. And then this juxtamedullary nephron, as you can see, the loop goes all the way down and comes back up. And this is the medulla area. That's where the pyramid lies. The pyramid is in, here's the pyramid, and the pyramid is in the medulla area. So since the juxtamedullary nephron goes down into the pyramid, that means it goes down into the medulla region. So that's why it's called the juxtamedullary nephron. So let's start with the renal corpuscle. That's the sphere that it starts with, and that's called the renal corpuscle, or corpuscle, you can say either one. And the renal corpuscle is this little sphere, and on the outside you just see some tissue over there, and the tissue is called the Bowman's capsule, the sphere-like container. It's empty, it's hollow, and it's not empty, but it's hollow inside, and it's called the Bowman's. This is called the Bowman's capsule. Because when you crack it open, I'm going to draw this, let's say we cracked this open, we sliced this in half, and now you can see the inside of it. Here's the Bowman's capsule around it, and it's like a bowl, a soup bowl. And inside, within the Bowman's capsule, there are just this mess of arteries, or capillaries. And capillaries, as you know, are very tiny arteries. And the capillaries enter through the afferent arterioles, and then that comes out the other side, called the efferent arterial. So afferent arteriole is coming in, means it's going into the renal corpuscle, afferent. And then there's the efferent arteriole, and that is going out. So I always think efferent exits. So efferent with an E, exits. So the afferent arteriole comes in, it makes this whole mess of capillaries, the blood leaves in the efferent arteriole, and we'll get to the efferent arteriole and where the blood goes after that a little bit later. But all you need to know right now is that the afferent arteriole is the incoming arteriole. It turns into capillaries, which are tiny arteries, and then the blood supply leaves through the efferent arteriole. So all of this to put together, this Bowman's capsule and the capillaries inside, is called the renal corpuscle. Just the capillaries inside, this mess of capillaries that sit inside of the Bowman's capsule, that is called the glomerulus. So here it is once again, the renal corpuscle, and the Bowman's capsule is the hollow sphere. The glomerulus are the capillaries inside, and then this has a tube coming out of the Bowman's capsule right here, and this is where the filtrate comes out. So this is where the liquid that's getting ready to be turned into urine comes out. Obviously, it's not going to come out in the bloodstream, out the efferent arterial. Instead, it's going to come out this little tube, and then it's going to do this convoluted thing where it curves up and down, folds up and down, twists around like this. And convoluted just means a twisting and turning. So this is going to be called the proximal convoluted tubule. So this is going to be the PCT, and that's proximal. Proximal means closest, so closest to the Bowman's capsule. Proximal convoluted tubule, because it's a tube. And we just abbreviate it the PCT. Now after the PCT, the tube is going to continue on, but it's going to go down and do a little loop-de-loop. Loop, loop, loop. And it's going to come back up. Now we call that the nephron loop, or it's also called the loop of Henle. And so we abbreviate that LOH. So this entire thing is the loop of Henle. And then after the loop of Henle, it does some more convoluted twists and turns, and that is called the distal, the DCT, the distal convoluted tubule. So distal, and distal means distant, so it's distant from the renal corpuscle. It's on the other side of the loop of Henle, so it's distal, it's distant. The distal convoluted tubule. And then that is going to empty into this duct that goes all the way down through the pyramid and empties out into the minor calyx. Now this duct has two parts to it. There's the top half and the bottom half. The top half is called the collecting duct because the top half is where all of the nephrons, distal convoluted tubules, empty in there. It empties into the collecting duct, which is the top half of this duct. Now the bottom half of this duct is called the Papillary Duct. And this just takes all of the urine that's been emptied into the collecting duct and it takes it down to the minor calyx. So this is called the Papillary Duct. It's just the bottom half of that collecting duct. So renal corpuscle is the Bowman's capsule and the capillaries, the glomerulus inside of there. All of those two together are the renal corpuscle. And then there is the proximal convoluted tubule. It's called that because it's convoluted. It twists and turns. And then the loop of Henle loops down. And then another convoluted tubule because it twists and turns, and that's the distal convoluted tubule. And that empties into the collecting duct, which goes down into its bottom half, which is the papillary duct, and it goes out to the minor calyx. And this is the flow of urine. up here, when it's just coming out of the renal corpuscle, it's called filtrate. But once it gets down about here, once it gets to the bottom of the loop, it's pretty much urine by that point. So here is a diagram of the same thing we were just going over, so you can see the picture of it. There is the afferent arterial, and that goes in. That's the blood supply in. Here's the efferent arterial, and that's the blood supply that exits. This entire region is the renal corpuscle. And within the renal corpuscle, it has the Bowman's capsule, and that's the hollow sphere. And then inside are a bunch of capillaries called the Glomerulus. And then we see this first twisting and turning section right here. So that would be the proximal convoluted tubule. Proximal because it's nearest to the renal corpuscle. And then this loops down. That's the loop of Henle, or the nephron loop. And then when it comes back up, it does this convoluted thing again, this twisting and turning, and that is the distal convoluted tubule because it's distant to the renal corpuscle. And then as you can see, that empties in to this collecting duct. And once it goes down the collecting duct, this turns into the papillary duct. And the urine goes out to the minor calyx. So how does the nephron make the urine? Where does the liquid come from? How does it get any liquid in there to make urine in the first place? So let's look at that for a minute. Here is a different picture of the nephrons. Here's the shorter one, so this would be the cortical. And here's the longer one, so this would be the juxtamedullary. But as you can see here, this looks different. Why? Because it shows you all of these arteries, these capillaries that are wrapped around the loop of Henle. See how all of these capillaries come down and wrap around? Well, that's from the Afferent Arterial. As you can see up here, here is the Bowman's capsule and the Glomerulus. This is the renal corpuscle up here. And here is the afferent arterial. So that's the blood supply coming in. And then here is the efferent arterial. And when that blood supply leaves, these are arterioles, which are small arteries. That leaves, and that bends around and starts going down and wrapping all the way around this loop of Henle. See, it comes down and it branches off, and it makes all these different branches, and it just wraps all the way around the DCT, the loop of Henle, and the PCT. So the loop of Henle and the PCT and the DCT, these tubule, has all of these capillaries wrapped all around it. So these capillaries are really close by this tubule. So keep that in the back of your mind as we go into how this urine is made. Now, once again, here's a close-up of the Bowman's capsule of the renal corpuscle. And what happens is you have this afferent arteriole, this entering miniature artery, and that's the afferent or in arteriole. So the blood flow comes in this way, and then they get skinnier and they turn into capillaries, and the capillaries are all in this mess, in this bunch, forming the glomerulus inside the Bowman's capsule. And then the capillaries the blood supply has to go out somewhere, so it exits, and it exits through the efferent arteriole. So efferent, exit, efferent exits, arteriole. So the blood supply comes out this way. But while the blood is inside the Bowman's capsule, while it's in here, in these capillaries, pretty much what happens is your blood pressure causes these capillaries to squeeze, and when they squeeze, the capillary itself has pores in it, has little tiny pores in it, just barely enough, not enough to like lose your blood so you're bleeding inside, but it has just enough little teeny tiny pores in it. When your blood pressure applies pressure on these capillaries, then it squeezes out the waste out of these pores in a liquid form. It squeezes out the water, it squeezes out just byproducts. The blood stays in pretty much, but it squeezes out particles that are smaller than blood cells, including liquids. And that comes out and into the Bowman's capsule, which is why the Bowman's capsule is there as a hollow sphere, because it collects all of this liquid that the capillaries are squeezing out, all of this waste liquid. And that is called filtrate, all of this waste liquid that got squeezed out of the capillaries. So I'm going to put up here filtrate. And then the filtrate exits out the other side, while the blood supply exits out the efferent arteriole. The filtrate that the blood squoze out of the capillaries comes out of the other side, out of this end, and it turns into the proximal convoluted tubule, where it does that convoluted thing. It twists and turns. So this would be the proximal convoluted tubule right here. So that's where the filtrate comes out. So here's a smaller picture of the renal corpuscle, the Bowman's capsule. Bowman's capsule with the glomerulus inside of it right here. And then here's the afferent artery. So here's where the blood's coming in. And here's the efferent artery. So here's where the blood's coming out. And here is the proximal convoluted tubule right here. And then what happens is the proximal convoluted tubule then turns into the loop of Henle, and it loops down and comes back up. And then that loop of Henle turns into the distal convoluted tubule. So here's the DCT, and here's the LOH, the loop of Henle. And this out right here, this efferent arterial. This continues on going out, and it comes around and it starts wrapping around the proximal convoluted tubule. It wraps around the loop of Henle. It wraps around like this, gets really close to it, and it wraps around the distal convoluted tubule, the DCT, and it wraps around like that. So you end up having these tubes full of filtrate. Here's a tube of filtrate squeezed out by the capillaries of the glomerulus, and then right next to it you have capillaries, these arteries, these miniature arteries from the efferent arterial, and they're right next to each other. So what happens is that as the filtrate follows this tube down and around, as the filtrate goes through this tube, it's getting passed back and forth, back into the blood supply, and then the blood vessel squeezes all the waste out back into the tubule. So just like in the renal corpuscle, those capillaries squeezed out all of the waste into a liquid, into the Bowman's capsule, and that's called filtrate. And then the filtrate went into the PCT, and as soon as it starts getting into the PCT, it's wrapped around with these arteries here. And so the filtrate gets absorbed back into the capillaries, and then the capillaries squeeze again, and they filter it again. So it's just like a double filtering method. And all of these capillaries that wrap around all around the DCT and the PCT and the loop of Henle that come from the efferent arterial, these are called peritubular capillaries. So it goes from the efferent arterial, and then that turns into the peritubular capillaries that wrap around the tube. So this action with the Bowman's capsule, and you have the capillaries in it, and the capillaries squeeze the waste out in a form of filtrate. Then the filtrate goes through these tubes, and then that's when they go back and forth between the peritubular capillaries and the tube, getting filtered again and again. So when the filtrate is first coming out of the capillaries in the glomerulus, that is called filtration. And then when they proceed through the tube and get to the peritubular capillaries that are wrapping around here, then that's when the filtrate goes back into the peritubular capillaries, because the peritubular capillaries are going to filter it one more time, see if there's anything they missed, if they need any more nutrition. Maybe they squeezed out some vitamin C on accident and they want their vitamin C back, or whatever, back from the filtrate. When it goes back into the peritubular capillaries, the filtrate does, then that is called reabsorption. And then the capillaries pick through the filtrate and take anything that they need, any nutrition or anything, so there's not nutrition in the urine. And then they squeeze it back out into the tube again, into the tubule again as urine, and that is called secretion. So those are the 3 steps to making urine. Filtration, which happens in the renal corpuscle with the Bowman's capsule and the glomerulus, and then reabsorption, and that's in the proximal convoluted tubule and part of the loop of Henle. And then the last half of the loop of Henle and the distal convoluted tubule, there is secretion, where the capillaries squeeze the filtrate back into the tube as urine. And then, as you can see, here's the distal convoluted tubule right here. After everything's gotten squeezed back into the tubule as urine, and it empties into this collecting duct. It goes down the collecting duct, and then the collecting duct turns into the papillary duct, and then it goes out the bottom of the pyramid. Here's the bottom of the pyramid, into the minor calyx, and then out to the major calyx, then to the renal pelvis, and then out to the ureter, down to the bladder. Now, as I said before, there are 2 types of nephrons. The short ones, and that's and they stay in the cortical region, so they're the cortical nephrons. And then the long ones, and that's the juxtamedullary nephron. And that's the big difference between these 2 nephrons. The other difference is that in the short nephron, the cortical nephron, as I said, these capillaries that come and wrap around the whole loop and everything, those are called peritubular capillaries. But you see how it's a lot less messy, and they're more longer. They don't wrap around so much in the long juxtamedullary nephron. That's instead of peritubular capillaries, they're called the vasa recta. And it pretty much, they do the same thing. It's just a lot more intense with the vasa recta, so they make more concentrated urine. But pretty much everything else is the same. But just remember, the peritubular capillaries are for the cortical nephron, and the vasa recta is what it's called in the juxtamedullary nephron.